Hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome all our members into my channel and also kindly request us to subscribe, engage ourselves in the comment section, and also ring that notification bell to be getting updates on our various uploads in mathematics and sciences. Now, in our discussion today, we are going to look at the extension of about the moment of inertia for the x and y axis, which we have discussed in our previous videos. And of course, I'm going to use this specific illustration on my right in trying to emphasize on these two specific aspects of the moment of inertia. Now, in this case, we are going to look at a circle which is going to form our area. And of course, we're going to borrow from the concept of that area segment which we had discussed in our previous video in trying to make this point elaborate. Now we're going to consider the moment of inertia of an area A with respect to this specific axis which I've given in terms of A prime. Now in this case, I'm going to have these two specific axes for B prime and A prime, which are going to be the axis of our interest. And of course, we are required to find the moment of inertia with respect to the axis which is going to be given as A prime as such. Now, in this case, I've given this specific distance from A, given as the distance between these two axes given as y. And of course, we can see that basically y is the summation of this specific distance for D and y prime given as such. And we're going to consider this point of C as our center for this specific area. And DA is going to denote that area segment which we have been giving in our, of course, our previous videos. Now, in this case, we're going to consider some of the basic shapes which we have looked at in our previous videos. And these are going to give us some idea on how we can evaluate the area or the moment of inertia of an area with respect to this specific axis. Now, in this case, we had discussed the concept of an moment of inertia of a rectangle. And we can give this one in terms of this specific illustration, whereby we are going to consider this specific area as our rectangle. Now, if we have this stretch along the x-axis given in terms of b, while this one is going to be given in terms of y, then therefore we can take the dimensions of this specific rectangle in terms of h and b given as such. And therefore, the moment of inertia about the x-axis can be given in terms of a third bh cubed. And then we're going to have the moment of inertia about the y-axis given in terms of a third b cubed h given as such. So in this case, we are going to also look at other basic shapes, particularly three in number. So this is going to be a rectangle, and then we are going to consider a triangle. So basically, this is going to be a rectangle. So we're going to consider a rectangle, a triangle, and a circle in that case, which is going to be assisting us trying to do that specific evaluation. So we're going to have this specific triangle given as such. If we have its base given in terms of b and the height given in terms of h, so this we can do a rough just illustration for that one. So the moment of inertia about the x-axis of this specific triangle is given as. So we have done one of the examples of this specific evaluation in our previous examples in terms of a problem set. So in that case, you can just check our description boxes for a link which is going to contain that specific video. Now in this case, this is how we can indicate the moment of inertia of a triangle given as a 12 ph cubed given as such. And lastly, we shall look at the moment of inertia about, of course, or a moment of inertia about the x and y axis for a circle, which can be given in terms of this specific illustration. So we are going to have our circle given as that, and this is going to form our radius for y and x given as such. So the moment of inertia about the x and y axis is going to be equal for a circle, which basically is given as the integral over the square of y dA given as such. And in case if it's y, of course, we're going to have this one given. In case if it is x, we're going to have this one as the square of y. In case it's y, we're going to have this one as the square of x, as we have been doing from our previous evaluation. Now, therefore, we can proceed having stated these various formula for finding the moments of inertia for basic shapes, and then we can do an evaluation for the moment of inertia about a prime, which is basically the moment of inertia about the x-axis given as such. So in this case, our axis given as a prime, which is going to form our moment of inertia about the x, as we've said, is given as the integral as this of the square of y dA. And of course, we're going to consider this as specific axis, which is going to be given as b prime. So this is going to pass through C, a point that we refer to as a centroid, and therefore it's going to be referred to as a centroidal axis given as such. So therefore, for us to find the moment of inertia of this specific shape, we're going to consider that area element, and therefore give it in terms of the moment of inertia about the x-axis is equivalent to the square of y dA. And of course, we said that this specific stretch of y can be equivalent to the summation of a dy prime. So therefore, for us, we can do still an evaluation and give it as y prime and then plus d, the square of that dA. So I've just done a substitution of this specific y as a summation of the two. And then we're going to have this one. Now from algebra, we're going to do an evaluation of that one and find that the moment of inertia about this specific axis can be given as y prime, the square of that one, and then plus y prime d, which is going to be still giving us this specific aspect of. So we shall have this particular aspect of y prime d, y given as such. So we're going to differentiate this one with the respect to dy. So we're going to have this one as twice y prime d, so that we do not have a dy there. And then we're going to have the square of that one. And all of this is going to be dA given as that one. So we're going to find the integral of this, all of this one. So in this case, we're going to do an evaluation of the middle part, which we're going to see. So for us to find the various integral for these specific terms for the first one, second one, and a third term. So this is going to be given as the moment of inertia given as the summation of y prime squared, and then we're going to have this one as dA plus 2 d, the integral of y prime dA for the second term. And then lastly, we're going to have the integral or the square of d, the integral of dA given as such. So this is going to be giving us individual integrals for these three terms of this specific, of course, expression. And therefore, we are going to see that the middle section of this one for us in evaluating the integral is going to be equivalent to 0 from our previous discussions. So in this case, we're going to have the moment of inertia still given as the integral of y prime, the square of that one, dA, and then plus d squared. So this is going to be a combination of the first and the last term, which is going to be giving us this one. So the evaluation of this one basically is going to give us the moment of inertia about the x-axis is equivalent to, so I'm going to differentiate this one with a I with a symbol over that one, plus a. So that one, that's going to be plus a, the square of d. So we're going to find this one. This is going to be the square of d. The integral of this one is going to give us a. So in this case, we're going to see that this basically is going to reduce to an integral of this specific form, whereby we're going to see that this specific evaluation is going to give us the integral with respect to x, which is a summation of this specific, of course, moment of inertia with this symbol, and the product of a, d squared given as such. So we have talked about the concept of a as being the area. This is the difference in distance, which is basically going to be forming the radius from our previous discussion in that specific sense. So we're going to consider it to be this specific area distance, or d, which is a summation of course, the difference between y and y prime, giving us the value of d. So in this case, this specific formula is going to sum up what we refer to as the parallel axis theorem, that is going to give us the moment of inertia between these two specific axes given as a prime. And then this second one is going to be giving us the moment of inertia of this centroidal axis, which we have referred to as a bb prime given as such. So this formula is going to sum up for us what we refer to as the parallel axis theorem, which is going to be the moment of inertia with respect to these two axes, which we have considered in this specific general evaluation. So that is it for now, guys. Kindly check our description boxes for various links of other videos on the concept of moment of inertia and the general aspect of mechanics, which is going to be assisting us try to understand the, of course, the relationship between various topics which you have learned, especially in different topics in algebra, mechanics, etc. So that is it for now, guys. Bye, God bless you. Catch us in our next video.